What if everything you know is wrong?
For the longest time, science seemed to have dreaming all figured out. We were told it was just this chaotic, random side effect of our brain being asleep. But what if that's not the whole picture? Not even close. Let's get into the incredible new science that is flipping our entire understanding of why we dream on its head.
Seriously, just let that question sink in for a minute. Because the classic theory, the one that pretty much dominated neuroscience for generations, is now getting some major pushback from a really surprising place deep inside the brain.
For decades, this was the go-to explanation, the activation synthesis model. And the idea was pretty straightforward. During REM sleep, your brainstem just starts firing off all this random, chaotic electrical noise. Your higher brain, the forebrain, then does its absolute best to stitch all that nonsense together into some kind of coherent story. Your dreams basically were just your brain trying to make sense of static.
So, to really get why this model was so powerful for so long, we've got to look at where all the action was supposedly happening, down in the brainstem.
Right. This area, the brainstem, was seen as the engine of REM sleep, which meant it was also the engine of dreaming. It was thought to be the big on-off switch. Once that REM switch was flipped, the brainstem would start its noisy, random signaling, and the forebrain's only job was to passively catch all that input and try to turn it into the bizarre movies we call dreams.
But here's the thing about science. It's all about poking holes in theories. And it wasn't long before researchers started finding some pretty massive cracks in this neat and tidy story. Okay, so this slide gets at something called a double dissociation. And trust me, in neuroscience, this is a huge deal. The old view was that dreaming was basically just a shadow of REM sleep. They were attached at the hip. You couldn't have one without the other. But the new evidence showed that, well, you absolutely can. You can have REM sleep without any dreams, and you can have super vivid dreams without being in REM sleep at all. And this wasn't just some rare exception. I mean, if you look at the actual numbers, it's a huge problem for the old model. About a quarter, a full 25% of all those vivid, story-like dreams we have actually happen outside of REM sleep. That's a massive chunk of our dream life that the classic theory just can't explain. And here's the real knockout punch. It comes from studying people with very specific brain injuries. So check this out. On the left, you see the brainstem. When that part was damaged, patients couldn't go into REM sleep anymore. But guess what? They kept on dreaming. Now look at the right, the forebrain. When a totally different area up there was damaged, patients stopped dreaming completely, even though their REM sleep cycles were perfectly fine. It was a crystal clear sign that REM and dreaming are run by two different systems.
So, if the brainstem isn't the dream maker, then what is? This mystery sent scientists on a hunt for a new suspect, and they found a big one. A really powerful pathway located right in the forebrain. Say hello to the new star of the show, the mesolimbic dopamine pathway. Now, this is not some random corner of the brain. This is a core circuit. This is the system that's all about our most basic drives: motivation, reward, wanting things, and going after them.
The brilliant neuroscientist Jacques Pangsep called this the seeking system. It's the part of us that pushes us to explore, to get curious, to engage with the world with a sense of purpose and desire. And the incredible new theory is that this exact same system is what lights up at night to generate our dreams.
And the evidence for this is just so compelling. First off, in old surgical procedures where doctors would cut this pathway, patients reported that they just stopped dreaming completely, even though their REM sleep was fine. Second, you look at drugs like L-Dopa, which floods this system with dopamine. What happens? People report incredibly intense, vivid dreams, but it doesn't change their REM sleep one bit. And on the flip side, drugs that block dopamine, like antipsychotics, can actually turn dreaming off.
So what this all points to is a totally new model. Dreaming isn't a one-step thing. It's more like a two-step dance. First, something has to give the brain a little jolt of activation during sleep. Yeah, REM is a common trigger, but it's not the only one. But here's the crucial second step. That activation has to light up the forebrain's dopamine-driven seeking system. That system is the final pathway to actually having a dream.
Okay, so all that clinical evidence is powerful stuff, right? But scientists found something even more direct. This is the smoking gun, the definitive proof that the forebrain could create dreams all by itself.
Just listen to this quote for a second. It sounds exactly like someone describing a wonderful dream, doesn't it? Well, the person who said this was not asleep. They were wide awake. This whole experience was generated artificially, just by stimulating one tiny part of their forebrain.
In this absolutely mind-blowing study, researchers used something called deep brain stimulation, or DBS, to send these tiny electrical currents into the amygdala, a key emotional hub in the forebrain of patients who were completely awake and talking with them.
And what they found was just astonishing. At really low voltages, patients would suddenly report feeling happy, even euphoric, and they'd see these vivid, pleasant, dreamlike images in their mind's eye. But if the researchers turned the voltage up just a bit, that same stimulation would produce negative feelings like anxiety or anger. They could literally dial a dreamlike state up or down.
And here's the wildest part of the whole thing. The patients described having a double consciousness. They knew perfectly well that they were in a hospital room talking to doctors, but at the exact same time, they were experiencing this incredibly rich, vivid inner world, almost like they were a spectator watching a movie inside their own head. They could tell the difference between reality and the dream, which proves the brain can generate these states without needing to be asleep at all.
So what on earth does all of this mean? Well, it gives us a completely new framework for understanding what dreams really are, and maybe even what they're for.
The big takeaway here is this. Dreaming isn't just your brain tidying up random static from the brainstem. It is a meaningful psychological process. It's being built by the very same sophisticated systems in our forebrain that when we're awake are driving our ambitions, our fears, our desires, and even our most creative ideas. So let's just recap the key points. First, dreaming is a forebrain job, not a brainstem job. Second, because it's run by that dopamine-seeking system, our dreams are fundamentally wired into our core motivations and our deepest emotions. And third, and this is just so cool, the fact that we can stimulate these novel, original images suggests the brain might be using the exact same networks for dreaming at night and for creative thinking during the day.
And this all leaves us with one final and kind of provocative thought. If dreams aren't just random noise, if they are actually a product of the deepest, most motivational and emotional parts of our minds, then what does it mean when we ignore them? What part of ourselves are we choosing to tune out? And that is definitely something worth thinking about.
Understanding begins with why.